Coming to the third problem on the maximum power transfer. The question is, for the network shown in figure, find the value of ZL that will transfer maximum power from the source and calculate the maximum power. The diagram given is 200 angle 0. Here you have ZL, and finally J5 plus minus 4 times Vx. Now in this case you have the dependent source, so our approach will be, we'll find Vth and IN, and then we'll find the Zth. So solution, finding Vth, that is calculating Vth. For that I'll redraw the circuit. This is 4 ohms minus plus Vx, 200 angle 0, Vth, J5 ohms plus minus 4 times Vx. Let us assume these terminals to be AB. Current flowing is I can say from figure. Vx is 4 times I. Current is flowing from positive to negative terminal, so Vx is 4 times I. Now I'll apply KVL to the mesh. KVL to the mesh will give me 200 angle 0 minus 4I minus J5 into I minus 4 times Vx is equal to 0. Now Vx is 4I. I'll substitute in this. I'll get 200 angle 0 minus 4I minus J5I minus 16I equals to 0. So 200 angle 0 minus 20 plus J5 I equals to 0. So I can calculate I as 200 angle 0 upon 20 plus J5. So it will be 9.7 angle minus 14.03 degrees ampere. So I have got I. Once I know I can find Vth. So for Vth, equation will be 200 angle 0 minus 4I minus Vth is equal to 0. So 200 angle 0 minus 4 into 9.7 minus 14.03 minus Vth is equal to 0. So after simplification I'll get Vth as 162.62 angle 3.31 degrees volt. So I've got the value of Vth. Now we find the value of In. Calculating In. So for that the diagram will be 4. This branch will be shorted, plus minus 4 times Vx J5 4 200 angle 0. Current is IN. Let us assume I1 in mesh 2, mesh 1, and I2 in mesh 2, minus plus Vx. I can say Vx is 4 times I1. Now KVL in mesh 1. KVL in mesh 1 will give me 200 angle 0 minus 4 times I1 is equal to 0. So straight away I can find value of I1 as 50 amperes. Now KVL to mesh 2 will give me minus J5 I2 minus 4 times Vx is equal to 0, or I can say minus J5 I2 minus 4 into 4 times I1 is equal to 0. So you can find I2 as minus J5 I2 will be 800, or I can say I2 will be 160 angle 90. So this is how we have found the value of I2. Now IN is I1 minus I2, that is can find it as substituting I1 and I2, that is 50 minus 160 angle 90. So this will give me 167.63 angle minus 72.64 degrees ampere. So I have got the value of IN and VTH. So once you know the value of IN and VTH, you can find ZTH. So ZTH will be VTH upon IN. So that is VTH, we have got it as 162.62 angle 3.31 upon 167.63 angle minus 72.64. So ZTH you will get it as 0.2355 plus 0.941 J ohms, or in the polar form you can write it as polar form 0.970 angle 75.95 degree ohms. Now we can say for maximum power transfer, ZL should be complex conjugate of ZTH. So I can say ZL will be 0.2355 minus 0.941 J ohms. So once you know ZL, you can find maximum power. So the diagram will be, this will be ZTH, which is 0.2355 plus J.941, and this will be ZL, which is 0.2355 minus J.941 ohms, and VTH, which is 162.62 angle 3.31 degree volt. So we can find maximum power as mod of VTH square upon 4 times RL. So this will be 162.62 square upon 4 into 0.2355. So you'll get maximum power as 28073.5 watts. So this was the problem with the dependent source. So this is how we can solve the problem on maximum power with dependent source.